All right, so this is page 18 and 19, which you are going to be, well, that you should be working on Wednesday. And since we're not really starting it together, I wanted to kind of give you a chance to kind of warm your brain up since we're dealing with some bigger numbers. I want to show you the algorithm and the box method for a couple of each of these problems. So we're going to start with, on page 18, we're doing 6 divided into 732. So I'm going to set up my box method in case that's the way you choose that you want to do it. So I want you to have that set up. Remember, you can use binder paper or some kind of scratch paper. Anything's fine. 732. All right. You'll notice that when I set it up, I make sure that I have room in front of my numbers. So if I have to unbundle, I have a space to do that. All right. So remember, we're doing both steps. We're going to kind of almost work these at the exact same time. So you have to decide if you're really going and understanding the algorithm, you don't need to worry about the box method. Okay, so if you're like, I'm getting this algorithm, I got this, then you don't need to worry. But for those of you that are still kind of struggling a little bit with that algorithm, try the box method again and see if it works for you. Okay, so I'm actually going to do the box method first. So those of you that like the algorithm, you could think about how you would fill that in right now as we're doing the box method. So first thing I'm going to ask myself, I know I'm thinking 6 times something gets me as close to that number. So 6 times what gets me as close to 7? Well, if I skip count by 6, 12's way too big. So there's just 1 6 and 7 because 1 times 6 was my 6. Couldn't get any closer, so now I'm going to subtract. I get a 1. I compare. It's definitely less than my divisor, so I'm ready to bring over or down depending on what you're doing. Bring that. So now I have a 13. Okay, now I have a 13. Think about where that 13 would be. 6 divided into 13. 6, 12, well, definitely 12 is as close as I can get, but how did I get that 12? Yep, 6 times 2. The 2 is what goes up here because 2 times 6 is 12. That was as close as I could get. My 12 goes under my 13, so I can see what I have left, which is, of course, 1. I compare. It's less than my divisor, so I'm going to unbundle that. And look what I have, a 12. Well, 6 divided into 12, I know that already. It's 2 because 6 times 2 is 12. Can't get any closer, and I do not have a remainder. So now I want you, if you did that the box method, you can see how that worked. And I want you to relate it to the algorithm because that's what we're going to do now. Please remember that in these videos, if I go too fast, pause it or go back and watch it again. That's the great thing about this, is that you have the ability to do that. So now we're going to do the same thing with the algorithm. For those of you that prefer that, same idea. 6 divided, and hopefully some of you are already doing that, so you're going to have your answer. 6 divided into 7 is 1 because 1 times 6 is 6. I subtract. I get a 1. It's less than my divisor, so I'm ready to bring down the very next number, which is a 3. Then I'm going to do 6 divided into 13. Okay, well, that's 2 because 2 times 6 is 12. I can't get any closer without going over. Now I have 13 take away 12, which is 1. Definitely less than my divisor, so I can see, yep, one more bring down. I got to bring my 2 all the way down here. Got a new number. It's 12. 6 divided into 12 again is 2 because 2 times 6 is 12. Subtract. I have no remainder. And I know that's my remainder because there's nothing left to bring down. We're not dealing with decimals, so we're just deciding whether our remainder is a whole number or not. So, as you can see, no matter how I did it, I got the same answer. All right? So now we're going to try one more. So I'm going to set up my box method. And this time I'm going to do 6 divided into, and I've got to have 3 boxes because I have 3 digits, 942. All right, so again, if you like the algorithm, while we're doing the box, try to do the algorithm. See if you can solve that while we're doing this. And if you like the box method, I want you to really be filling this in because I'm going to take my time on this one. All right? So remember, you can do whichever way you prefer. All right. But I'm going to do the box method first, so you decide. First question. I'm going to shrink it down to make it just 6 divided into 9. So I'm still thinking 6 times what? That's my division. Gets me as close to 9. So, figure that out. Hopefully you put 1. Because I can't get any closer to 9 than 6. If I had a 2 here, that would have been a 12, and that's too big. So 1 times 6 is 6, and I can subtract, and I can see I'm going to get a 3. Now I'm going to compare. Is it less than my divisor? Then I'm okay, as long as it's less. So now I'm going to bring over. If you're doing the algorithm, you are bringing down. I have a whole new number now. I have 34. So I'm going to start again. 6 divided into 34. So skip count. Use your 6 songs. Sing it. If you don't know your 6 songs, you better go start singing those multiplication songs with me. It's in the stream. Sing them every day. All right. 6, 12, 18, 24, 30, 36. 36 is too big. So I couldn't do 6 times 6. Good. Hopefully you figured out what number goes up here. It's a 5. Because 30 was as close as I could get. How did I get that 30? 6 times 5. So 6 divided into 34 is 5 because 5 times 6 is 30. But I know I'm going to have something left over. In this case, it's a 4. So now I'm going to compare. Well, it's still less than my divisor, so I'm doing okay. So I'm going to now unbundle it. Now I have a 42. Well, the last time I had a 34, and the answer was 5, so I know my answer is going to be bigger than 5 over here. So skip count by your 6s, figure out how many 6s are in 42, and write it down. All right. Hopefully by now you've got it. You should have a 7 because 7 times 6 is 42. You can't get any closer to 42 than 42. And when I subtract, it's clear that it's less than my divisor. I am now done. My answer was 157. Now, hopefully those that were doing the algorithm, you got the exact same answer. If you didn't, you made a mistake. So again, looking at that algorithm, I do the same thing. 6 divided into 9 is 1 because 1 times 6 is 6. When I subtract, I get a 3. I compare, it's less than my divisor, so I'm ready to bring down. There's my 34. Now I've got to repeat. So 6 divided into 34, we said was 5 because 5 times 6 was 30. I subtract, I get a 4. I compare, it's less than my divisor. Whoop. So I'm ready to bring down. There's my 42. 6 divided into 42 is 7 because 7 times 6 literally is 42. Can't get any closer. Subtract. Obviously, it's less than my divisor. Good. Okay, so that's page 18. What we're going to do now is we're going to flip to page 19 and do a couple of those problems. So flip on over. Now we're dealing with 7s. Ooh, 7s. Dun, 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 dun. Okay. So I'm going to set this up the box method again. And yeah, I can do it right here. So I know that my box, since I'm dealing with 3 digits, it has, wow, I made that one really small. I should make it a little bigger so that we can see it better. It's okay to make your box bigger if you need to, because I made that one pretty doggone tiny. So now I'm going to go, whoop, hundreds, tens, ones, dividing by 7. That's my divisor. My dividend is 854. I don't know my quotient or answer yet. But I'm asking myself, through this whole page, they're all 7s. So you're asking yourself, 7 times what gets you as close to that number in the box without going over? Okay, so 7 divided into 8, well, 1 7 is 7, 2 7s is 14, which is clearly too big. I would say 7 divided into 8 is 1 because 1 times 7 is 7. I should bring my card over. When I subtract, boop, I get a 1. I compare, it's definitely less, so I'm going to unbundle and bring it back over here. So now I have a 15. So right now I want you to stop and think. 7 divided into 15. 7 divided into 15. If you don't know your sevens, you need to go sing that 7 song every day for a week until you know your sevens. It's in the stream. But you should know this one. It's 2. 7 times 2 is as close as I could get because it is 14. Remember that 14 is what goes close to the, so 7 divided into 15 is 2. Because 2 times 7 is 14. Subtract, I get a 1 again. I'm going to unbundle, bring it, well, isn't this convenient? I think we all know the answer to this one. 7 divided into 14. Yeah, you better put a 2 there because 2 times 7 is 14 and I have no remainder. Okay, so just because it's a bigger number, the steps are all still the same. And luckily this whole page is sevens. So it's going to help you practice your sevens facts as well. So now we can see what we did with the box method with our sevens. And we're going to relate it to our algorithm. I'm actually going to use that. Look. 7 divided into 8 is 1 because 1 times 7 is 7. I subtract, I get a 1. I compare, it's definitely less, so I can bring down the next number, which is a 5. Now I have a 15, just like there. 7 divided into 15 is 2 because 2 times 7 is 14. I subtract, I get a 1. I compare, it's less, so I'm ready to bring down the next number, which is a 4. 7 divided into 14 is 2 because 2 times 7 is 14. Subtract, and there is no remainder. So I want you to see that these steps are literally the same thing. But like I said, some students prefer this box method because they can picture the unbundling and they don't get as confused as to where to bring what down. So you need to know that that is always okay to use, whichever way works best for you. All right. So I think that's a pretty good start. I think you have done enough practice by now that you can try to solve more of this on your own using the strategy that works best for you. And on Thursday, we're going to go over and correct these real quick. All right. Awesome job. Oh, and by the way, if you still are a little stuck, remember you can always go back and watch a video to remind you about that box method. All right. Don't forget the